Today we're going to learn a method to solve quadratic equations. Now if that word doesn't look familiar to you yet, when I say the word quadratic, I'm just talking about something like this, like x squared equals 4 as a quadratic equation. And the reason we call it quadratic is it's got x squared in there, and you're trying to solve it here. So if you take the square root of both sides, we learned this the other day. The square root principle says, don't forget, plus or minus. So you've got here x equals plus or minus 2. And you notice oftentimes with quadratic equations, you'll get two solutions. The reason for that is because of the shape. Again, quadratic equations have a certain shape, and they may look something like that. And so you can see that the solutions are wherever it crosses the x-axis. So it's very possible that this would have two solutions, although sometimes it has one solution or zero solutions. You can see that if this was up here, it might only have one solution, or maybe even it doesn't cross the x-axis and it has no solution. But typically, it might have two solutions. So what if it was just a little bit harder? I mean, that'd just be too easy, right, for our class. So you've got x plus 1 squared equals 4. Well, that's getting a little bit harder. To solve something like that, you take a very similar approach. Maybe take the square root of both sides. Don't forget plus or minus. And you get x plus 1 equals plus or minus 2. Now, you're not quite done solving, but it's not hard from here. Just subtract 1 from both sides. You get x equals negative 1 plus or minus 2, which again is really two different answers here. That's negative 1 plus 2, which is 1, so x equals 1. Or negative 1 minus 2, which is x equals negative 3. And so we got two different solutions here. Now that's really our goal. If we can get something that looks kind of like that without the square root there, some binomial squared, some perfect square binomial, and then you've got this, this constant, this number off to the right hand side, that's really the key to our method working. If we get to here, we don't need steps to figure out the rest of this. We can solve that in our sleep. That's no problem. That's a piece of cake right there. Okay, so we're going to learn a method. And to do this, you have to understand what perfect squares are. And sometimes I say this to students, and they don't know what I'm talking about. What's a perfect square? Well, you have to understand what perfect squares are. If you had a square and you found the area of a square with dimensions of 1, is side squared, which is 1. If the dimensions were 2, the area would be 4 there. 1 and 4 are both perfect squares. In fact, it's very possible you know the next one, 9, maybe all the way up to 13 and 13 squared, which is 169. So you might know your perfect squares. Those numbers should look very familiar to you. Now this is algebra 2. We're stepping it up a little bit here. So we're going to use not just numbers here, but we're going to talk about binomials, like x plus 1 quantity squared. That's actually a perfect square. We can figure out what it is. So to do that, let's put x plus 1 and x plus 1. It's the sides of our square. And to find that area, we're just going to have to multiply that. So we're going to say x plus 1 times x plus 1. There's going to be a lot of distributing here. Now when you multiply that out, first times first is x squared. And I often like to do the inside-outside part, 1 times x, and x times 1 is, you add them up together, that's really plus 2x. This bothers me there. There we go. That's a little bit better. Plus 2x, plus, and then last times last, 1 times 1 is 1. So we've got, this is actually a perfect square here. X squared plus 2x plus 1. It's a perfect square trinomial. So we love getting trinomials like this because they factor nicely. In fact, they work out to be a perfect square binomial, and you can just see that's a perfect square there. Now, to show you the pattern here, because I really want you to see a pattern here with the numbers. So if you were to use an expand command on a CAS calculator, you can say x plus 1 squared. It'll actually do the work for us here. So I'm going to copy that off here. We go back up to there, and do x plus 2 quantity squared. So when I expand that, it's x squared plus 4x plus 4. And if I do that again, and again, I'm going to change this to a 3. And do it one more time. Oops. And change that to a 4. And usually that's enough for students to kind of see the pattern there. You just bring that over there, you can see it. So you can see the pattern here, x squared plus 2x plus 1. Maybe you might even be able to guess what the next binomial squared there, keeping that pattern alive. In fact, you probably know what it is. X squared plus, if I told you this was 10x, I bet you could tell me what that is, right? What number would go right there? Well, how'd you get from 8 to a 16? A lot of times students see a pattern here. They go from 6 to 9. How do you get there? How do you get from 6 to 9? And they see a pattern here, and they see that if you take half of 10 and square it, you get 25, and that would be the number that would go there. And so that pattern, which really comes from this, if you think about it, if you have x plus a times x plus a, and you square those, you get x squared plus, let's do inside outside, ax plus ax is 2ax plus last times last is a squared. So you can see that if you just take half of a, because it's got 2a, and square it, you get this term. That's really the key to understanding this new method. This method has a name. It's actually, it's a really neat, I don't know if you see the beauty of mathematics, but this is a beautiful method. It's really elegant when done right. It's called complete the square. We can solve, the nice thing about this, you might say, well, why wouldn't we just use factoring? You just told us factoring was, quicker, easier. It is. Both those things are true, but factoring only works on some problems. And we're going to start with one that factoring would work just fine, but we'll work to an example here in a minute where it's not going to be possible to factor. So x squared plus, let's try, let's do minus, in fact. Let's make this a little harder. So minus 8x minus 9 equals 0. So we're going to solve this quadratic by completing the square. Well, again, I want it to kind of look like that form. Remember that problem we had a minute ago? X plus 1 quantity squared equals 4. I kind of want a binomial inside that's squared and some number over here, just a constant over on that side. So first thing I might do is I want it to look like that, so I'm going to move this constant over to the other side. So I've got x squared, that'll kind of give us a fresh start here. Minus 8x plus blank equals 9. So I added 9 to both sides to be fair. And I got to figure out what number goes there. Well, we just talked about this, right? If you know this number, what do you have to do to get to that number? Well, you take half of it, which is negative 4, square it. Negative 4 squared is 16, so I'm going to add 16 to both sides. So I'll add 16 to that side and 16 to this side. And so this side should factor really nicely here. In fact, it should be not just any old factors here, but really easy factors that it's really the same factor twice, because this should be a perfect square. This is a perfect square, right? We made it a perfect square. That was the goal of, that's what we're trying to do here. We're trying to get a perfect square. So I know this will factor really nicely. So I'm just going to say 16 has got to be 4 and 4, because the factors have to match. And this is minus 8, so this would be minus and minus. In fact, a lot of students go right from this step to this step after just a little bit of practice here. So you get x minus 4 squared. Over here you got 25. And now it looks a lot like we want, right? It looks like that, so we know we can just take the square to both sides. We don't even have to think from this point forward. It's just easy peasy solve this guy. So we get x minus 4 equals plus or minus 5. Add 4 to both sides, so x equals 4 plus or minus 5. We know that works out to be two different answers, 4 plus 5 is 9, or 4 minus 5 is negative 1. So I got two answers there, and I've solved it. Now, again, we could have solved this pretty quickly just by factoring. I mean, this guy factored really nicely. Would have been much faster in this case. So you've got 9 and 1. The bigger number is negative here, so I'm going to say minus and plus. And you get x equals negative 1, or x equals positive 9. And you're done a lot quicker. But again, factoring only works on some problems. It doesn't work on all problems. So let's try one where factoring doesn't work. We're going to make this one a little bit harder. Let's try 2x squared plus 5x plus 3. Actually, you know what? I think that one factors. I'm gonna change that. I'm gonna make that 2 here. I think that factors. Let's make this 1. I know that doesn't factor. Okay. So we've got something that doesn't factor here. We could try to factor this, but I'm pretty sure it doesn't work. I haven't worked it out, but 2x plus 1, factors of 1, it's not going to work there. So we're going to try our complete the square method. So we're going to go through the steps that we need to do, but this guy really causes us some issues. So anytime you have a coefficient, that's problematic for completing a square. It's not going to be easy or nice if we have a coefficient there. So I don't like that to have that, so I always like to start without a coefficient there. I'm going to divide everything by 2 here. Divide by 2, divide by 2. So that's going to cancel there, which is really what I want. I want the first term to be just plain old x squared. Now, I told you completing the square is a little harder than factoring. And one of the reasons is we really got some fractions, and you've got to just be okay with that. That it's okay, we can handle fractions. So again, same kind of technique. So we want this number off to the other side. If we want to get the way we're supposed to get it to look like here. We want a perfect square. So plus 5 halves x plus blank equals, I'm going to subtract negative 1/2 from both sides, and you get that. And if some students who do this, they know they're going to add something there to both sides to be fair. Now again, how do we get from here to there? Well, we take half of this number. Well, what's half of 5 halves? Well, half of 5 halves, of means times here, so we really got 5/4. Now what do we do that number? We take 5/4 and square it, and we put it here. So 5/4 will be, squared would be 25 over 16. And so we've got 25 over 16 on this side as well. This looks like a monster. We maybe not factored anything this difficult. Got fractions in there. It looks really hard, but again, since we kind of know the pattern, math is all about patterns. If you see that, it's really going to help you out here. So we've got x and x. Well, that's not so bad. And I know, remember last time we just took the square root of this guy. It's going to be the same factor twice, so it's got to be the square root of this. So square root of 25/16 would be 5/4. So I know that's going to be 5/4. This is plus. Let's think about that for a second. 5/4 plus 5/4 is 10/4. And if you cancel, you get 5 halves. So that works. That adds up. That's going to work really nicely. In fact, over here we've got x plus 5/4. Almost to my favorite part here. Just a second, we're almost there. Just wait, kind of delayed gratification here. I want to get a same denominator of 16, so we do 8 and 8 here. And I get negative 8 over 16, so plus 25 is 17 over 16. So I get 17/16. Kind of a weird number there. Okay, now we're ready to complete the square here. This is kind of the step, whoops, forgot something there. This side is squared. And you put those together and write it like a mathematician writes it here. You're going to be okay. Now don't forget your plus or minus. You get x plus 5/4 equals, this is so nice how this works out here. Now watch what happens. I'm going to write this, the denominator is square root of 16, which is really 4. Isn't it interesting how that matches? And up top it's kind of messy, it's square root of 17. That's okay. And so we get x equals negative 5/4. I always like to write that number in front here. Before the plus or minus, it just looks a little bit better. 4 and square root of 17. And that's really your answer. You can pretty it up a little bit here, maybe simplify it and write it as one fraction. So we could say negative 5 plus or minus square root of 17 over 4. But really that's all the simplifying we've got there. And so we've got our answer to a really pretty intense problem using complete the square. So if you're not afraid of fractions and you want an elegant way to find a solution, complete the square is the method for you.